Just checking some settings. Awesome. Welcome back to our Wednesday live streams. This is Praveen, developer advocate at Hasura. So today we're going to do a stream on Deno. I'm going to build like a simple GraphQL server on Deno and add it as a remote schema uh, and an action on Hasura, and then see how things go. So I think we'll do like an intro for Deno for those who are not very familiar with it. And we'll dive into a simple framework, a web framework with Deno. And then we'll see how we can add a GraphQL layer for Deno. Right, so going back to, I'll just post the link over here in chat. And this, yeah. Cool. So as you can see, like this is like a secure runtime for JavaScript and TypeScript, right? So the creator of Node.js, Ryan, he's basically been working on this, like a fork of Node.js types, but like a re-architecture of what he envisioned Node.js to be. So some of the things have been improved over here in Deno. Things like how do you do like network access, like all the security aspects around your application, right? So with Deno, everything runs in a sandbox. So you need to explicitly give access to those operations on that. So like networking, I/O, accessing environment variables, and so on. So everything needs explicit access. So that's like a primary difference on top of my mind. And the way modules are being handled is also fundamentally different. With Node.js, you have this centralized registry like npm, and then you do npm install the module, and things get downloaded, right? So with Deno, things are slightly different. Anybody can like self-host their own package. It could be on any URL. It could be like a GitHub repo, and just do an import of that URL, right? So that's like one of the other big differences with the way which Deno handles things. And Deno is like a single executable file. You can also like write TypeScript out of the box. So Deno supports both JavaScript and TypeScript out of the box. Runs on V8 engine. So yeah, that's like a small intro to what Deno is. So if you're familiar with Node.js and Express, we are going to use something very similar on Deno today. We're going to use a framework called Oak. Open that. So this is like a middleware framework for creating like a HTTP server, right? So if you look at the documentation over here, you can see that there is imports happening from a URL, and then it's being accessed, right? So in Express, you would have done like a require or an import from the module, which you would have pre-installed before. So this is slightly different. The approach here is different, and obviously you might be wondering, like, now where is there a package.json, right? The one that you typically have with a Node application. Technically, there's no package manager over here. So, but you have like you can have like your own dependency mapping system to just say what are the different modules that you maintain or you're trying to import into your application, and then like have a shorthand notation for them. So that's primarily what you can do here, and that's what we're going to explore today as well, right? So Awesome. So I'm going to start with the Oak server, and then I'm going to make use of this middleware for GraphQL. So Oak has this GraphQL middleware, which lets you apply GraphQL types and resolvers uh, to creating a GraphQL endpoint, right? So this is something that we will use. We'll create an endpoint. We'll define some types, and then we'll have that endpoint up and running on cloud as well. Um, I also wanted to point out the other framework called Obsidian. This would be like a full stack framework, which runs on the client and server. Client would be like a React app, which is server side rendered. There is caching, and on the server, this like you can do the typical GraphQL server that you want to write, right? So this is another module that we can use, and remember both these modules work with TypeScript out of the box. So that's something to note with Deno in general. You can create TypeScript files. The switching between TypeScript and JavaScript is pretty seamless. But yeah, that's where Deno stands right now. And to start off, I'm going to use the Oak server to just define an application, like a server to run some particular port, and then see where things go. So let me just copy the initial boilerplate. I have this Deno GraphQL repo. I have this server.js. This could be like a TypeScript file as well, like your typical index.js file that you have in Node applications. Right, so I hope the screen is visible. Yes. Cool. So I'm importing like an application from this Oak module. So this is coming in from a URL, but the first time you run this module will be downloaded. And the other interesting bit is that this won't be obviously downloaded every time you run this. So Deno caches these modules in your cache directories, depending on which platform you're in. In Mac, you will have a folder under cache, Deno caches. Linux will also have something similar. So different platforms will have different caching directories where these modules will be cached. And if there are some changes, obviously you can do a reload of these modules, right? So that's how this is done. And you can also like specify versioning over here when you are importing the module. So this is currently importing the latest version. I can also probably specify something like whatever version, whatever, right? So this is totally possible because you're just importing a URL at the end of the day, and as long as it's a module, things should work. This is very similar to creating an application on Express app, creating a new instance of application, and then here we're sending back a response body for hello world, and the app is listening on port 8000. Right? So let's see if this thing runs. Deno is like comes with the CLI tool, so you can do Deno help to see what are the different commands that are there. You have run, which runs the program. So we give the module name and then things start running, right? So here I'm going to do the same. I'm going to do run, and then I just created this server.js file. Yes, and if I see, it says that permission denied, network access. So run again with the allowed net flag. So this is the difference, right? So it runs in a sandbox environment. You need to give in special access to even access the networking stuff like port and host. And if you're accessing ENVs, you need to also explicitly give access to that, right? So I'm just going to see what are the other available uh, flags. I'm not sure if that will come up over here. Right, so I'm going to do Deno run, cloud.net, and server.js. And this should be running. So let's also probably add like a console.log, server listening at 3000. So this is just simple, plain old JavaScript that we write. Server listening at 8000. I'm just going to open 8000 and see if there's a hello world. Yes, we have the hello world, which is being sent back from this. Right, so awesome. So we've got the initial boilerplate, which is very simple, like 4 lines of code, importing some module, and things are working. Cool. So we have one comment from Drew. Just one suggestion: when you're in browser, do zoom in a bit. Thanks for doing these live streams. Awesome. Cool. So let me fix the zoom settings. I think VS Code looks fine for me. Let me go to the browser, zoom in up for these pages. This is fine, I guess. Yeah, so these tabs are fine. Cool, so we have like a hello world running. So next step is to add the GraphQL middleware, which is the oak-GraphQL. Again, this will be like another module that we'll be importing, which has the apply GraphQL method, which will create the server. So I'm just going to add this to my imports. And we have like a few methods and utilities being uploaded, like imported. So I have apply GraphQL, the GQL tag to define my GraphQL types. And there's GraphQL error. We can come back to this later. So we'll use apply GraphQL to create like a GraphQL server and GQL tag to define types and that basically to define types for GraphQL schema. So again, here, this is being loaded from a URL. This is oak_GraphQL. Yeah, this could come in from your own package as well, right? So that's what this is about. Next thing would be defining types. So we'll need to define our GraphQL types. And the other thing that we need to do is define resolvers and finally create GraphQL server. So broadly splitting up these into these 3 tasks, right? I'm just going to like create a simple GraphQL schema. Since we're going to use remote schemas with Hasura, I'm going to create a schema which allows us to merge data from these 2 sources. Deno being the first source, and Hasura being the primary source where you have data coming in from Postgres. So let me define some types. I'll add the GQL tag, and we can define type user, maybe, which can have like fields like ID, maybe int, and first name and last name. So this is first name, last name, string. Cool. Maybe you can also throw in some email. Right. So this is type user, and I can do like a root query for this, which would be type query fetch user, which would accept an argument, and it would return type user that we've just declared above. So this is just like returning one user at a time, this query. We can also do like a fetch users without any arguments and return an array of users, but yeah, sure. Next would be probably something for inserting a user. So after the query, I'm going to do like a mutation. This would be insert user. We can accept like a few arguments here as well. So this would be first name string, last name string, and probably the email as well. And it should return something. And for that, we'll just define another type. We can currently say this as user output. I'm going to declare that type user output. We can return back the ID of the user after the insert happens. So this is query mutation. We have the type user. We have like a user output, which returns just the ID. There's a query for fetching data. There's a mutation for the insert user, accepting 3 arguments. And in both cases, the arguments are mandatory. So this exclamation sign is indicative of that. Cool. So we have the types on the GraphQL schema ready, basically. We have the schema defined. The next step would be to define resolvers. So I'm just going to say resolvers here. And there are like 2 types of resolvers for us. There is one for query, and there is one for mutation. So fundamentally, like 2 types of resolvers that we are talking about. On the query, we have fetch user that we declared above. So we have to define this, then return back something. And on the mutation, we have insert user. This will also return us something. Cool. Now inside fetch user, this resolver will also have some arguments. A standard resolver in GraphQL will have these 4 arguments, which will be the parent coming in if there is data coming in from the previous field applicable in a nested query, right? So this is parent, this is args, which is the arguments that we might send in over here, which is the ID. So the ID will come in from the args. Then there is context, and then there is the info. This is very standard sets of arguments. Context is where your auth information would be typically available, your authorization stuff, and like the headers of authorization token and stuff. So, and it's available for every request that you make. And finally, for info, that would contain field specific information and also like the schema information of the fields. Right, so this is the boilerplate for our resolvers. We have the query and mutation. So now inside fetch user, we need to write logic to return something. Oops. Yeah. Logic to fetch data. Again, over here, write logic to insert into DB. Right, so on the user type, we have these 4 fields, the ID, first name, last name, email, and we need a way to like fetch data from somewhere and then return back, right? So I'm just going to hard code this data for now and then see what the results look like. So we need to send in an object back. So if you look at the type query, the output is of type user, which is like an object. So we have to return an object over here, which is of that type. Return some hard-coded values. So this would be my first name, last name, and email, which would be Praveen at Hasura. Cool. So we're returning this object based on some logic. In fact, on our args, we will also get the value for the ID, which we will be getting in from the query input. So you'll have arg ID that can be printed to see what that looks like, right? So then obviously we can use that variable to do some filtering on the data. Right, so this is fetch user. We'll come back to mutation, and then before that, we'll check if the query works with this hard-coded data. Finally, on the GraphQL server side, I'm just going to move this a little below. Probably we do not need this. We want to create a GraphQL server. And just going to go back to Oak GraphQL. Yeah, we have this apply GraphQL method that we need to call in. So, and then pass in type def and resolvers. So this would be like const GraphQL service, await apply GraphQL, and we need to pass in the router. So we need to import router from the Oak framework. This would be router shorthand notation, and we need to give the type defs, which should be types that we declared above. Yes. And then there's resolvers constant. So it would be resolvers. Yes, I think that's the key, right? Yeah, so this is resolvers. We don't have context right now, so we can skip that. But typically, that will be applicable if you have authentication enabled in your app. So we can come back to that later. This is GraphQL service, and then we can do like an app.use of GraphQL service dot routes, and then they have the allowed methods, which is the get and post, right? So I'm assuming this is just going to work for post for GraphQL service, and for get you will have like a playground service, right? So the GraphQL playground, which is like an alternative to GraphQL interface. So you can try out the queries and mutations and see if everything works fine. Right, so I'll zoom in a little more, maybe. This looks fine, I guess. Yeah. Right, so we have the basic setup done. I'm going to do a restart of this, and then I'll head to 8,000. Obviously, the get request for 8,000 will not work. This will be running on /GraphQL. So the GraphQL service that we created over here, this is running on /GraphQL. I'm assuming this can also be changed by specifying new endpoint. So this can be, let's say, API. I guess. Let me just restart and verify if that's the case. Obviously, GraphQL won't work now, so we'll have to switch to 8,000/API, and yes. So we have the GraphQL endpoint running in. I'll actually switch back to GraphQL because I'm so used to seeing that path. This doesn't need to be explicitly mentioned, but that's the configuration here. So we have the GraphQL service running on 8000. Let me do another funnel restart. Should work now. Now let's look at the docs. We have queries, which is fetch user. We have the schema coming up here, the types that we declared, and the arguments, which is mandatory. There's also a mutation, which comes up, which is insert user, accepting 3 arguments and returning a user output, which is ID. So yeah, the server is up and running. I can try out like a query. This would be fetch user, getting an ID of type integer, and I can get the ID, first name, last name, and email. So this is hard-coded data that's coming back from the server. This is working, right? So awesome. So what I'm going to do is modify or probably like load data from like a remote source and then see what this will look like. I have this JSON somewhere on my GitHub. So I'm going to make use of this JSON as my data source. And then I'm going to just like return back some data. So instead of doing like a hard-coded return over here, I'm going to do like a JSON response. So this would be, let's say, user request, which would be an await of fetch or else URL. And we need to make this an async function. We're doing an await over here, and then user response. This would be await user.json. Let me see what this looks like. User response. So we're just doing a fetch request to this JSON file, and we'll be getting some data back from that JSON. And let me just refresh this, make the query. So this is the data that's being read from the JSON on GitHub. Just going to do like a simple filter now. So current user would be user res dot filter user and check if the user dot id is equal to the args.id. So if you look at the console log, the first console is the ID1 object, which is coming in from this, which is the arguments that were received. And yeah, that's what we are returning back in the filter. So matching the ID with the user ID and then checking the args, right? So this is filter. And this would, if there is a data match, we would get like an array of users from this, right? So let me also do a current user. So let's say current user, and then do like a restart again. Right. So current user, this is fine. Let me do like 92. We got an empty array, right? So because the filter condition doesn't match for an ID2, there's no ID2 in the JSON file that we have given as an input. So yeah, things are working. So this is fine. Current user. So instead of returning this hard-coded data. I'm going to do return current user of 0. Obviously, this may not exist at all points. So if current user exists, then do, or maybe like current user dot length greater than 0, and do a current user of 0, else return an empty array, right? I'm gonna reload this. So one ID. Right, so I don't have the email coming in from the JSON, so that's fine. Cool, so we have the ID, first name and last name coming in from the JSON file. Obviously 2 doesn't have that, so we are getting an error. Cool, so let's add like a user, one more user into this. Right. Let me go to my downloads, users.json. I'm just going to add another user. The configuration is off. Let me add ID2 and first name. Let me take the comments from through to add this user. So this would be last name. Remove the last name from here. So this is fine. Right. We have the ID first name, last name for 2 users now. Submit. Git add comments. Git add users. Git add users. And push master. Cool. Let me refresh this. So we have 2 users now. Now, if I make the ID 2, I will get back this data. So data fetching happens from the JSON file. We are making a fetch call and getting some data from a JSON file and then filtering it out, right? So very simple logic. Obviously, this is the newest example, but you can go ahead and like configure DB requests. You can use something like db.users fetch, something like some kind of an ORM inside of this, depending on what fields have been queried, and then the ORM will contact the database and get back some response. That's the typical resolver stuff over here, so nothing fancy. Inside of this method, you can write in whatever logic, and this could be multiple HTTP calls to external servers or your DB to make database requests. In fact, you can also call Hasura GraphQL APIs from inside of this if there is a use case to do that. This could be like a simple fetch call, which makes a post request to Hasura and then gets back some data. Right, so that's queries. Right, so mutation, let's also do some hard-coded data and then see if that works. I'm just going to return an ID, like a hard-coded ID, because that's what we are going to return over here from the user output, which is of type ID. This is fine. write logic to insert a DB. Right, I'm not going to look into the ORM config yet, but um, that's fine. So we have a new user, Parikshit Chalke. Welcome. Sorry, you're connected late. So we are discussing how to do like a GraphQL server with Deno. Um, if you're familiar with or if you've worked with Node.js and some kind of a GraphQL server like an Apollo GraphQL server or like a GraphQL JS, the raw JS, you might be familiar with the types definition that you do for any GraphQL schema, the types of your fields and your root queries, the mutation and query, right? So that's what we've done. And then we've done some resolvers for those root queries, which is the fetch user and the insert user. For fetch user, we're doing some JSON fetch from a GitHub repo and returning some data. For the mutation, I'm just currently returning like an ID, which is hard coded. But yeah, we could do like a logic to insert into the DB and then return back some data. Right, so just refreshing this, and I'm going to do like a mutation for insert user. This accepts like a few arguments. I mean, I'm just going to do Praveen or maybe like a different user this time. Doesn't matter actually. So because you're not actually inserting into the database right yet. So I'm just gonna quickly do this. We finally have email, and as a response, we get back the ID. I'm going to get 1 because that's what I have returned over here. Cool. Your stack is Django, MongoDB, Flutter. Awesome. That's different spectrum of tools that you're using compared to what we're doing on the stream today. But nevertheless, Django, I think uh, you're probably using their own models. You're defining schema on them. And then I think you're using their MVC controller. So, right. So that's fine. And I think for your web app, if there is anything, then you might probably be using Django directly with the views. For Flutter, so you're basically exposing some APIs. Right? So that's fine. You should consider GraphQL in that case because it's well suited for like a mobile app and a web app combination where data fetching requirements are slightly different on mobile apps, but yeah, slightly lower requirement on the mobile because of the smaller screen sizes, and the web apps typically require like large amount of data. And that's where GraphQL shines. So do give it a shot. Awesome. So you have the GraphQL server running. So this is working fine. I'm gonna open Hasura Cloud, create a project quickly, and then see what's there. There's a free tire region. Let me select the US. This would be, GraphQL. And I'm going to try it with Heroku. Instantly created. So just going to click on create project. And just slightly zoom out a bit. Yeah, look at the comment again. So you've already worked with Hasura, so that's nice. Just going to give it a few more seconds till the DNS propagation happens. Right. So you use Flutter with mobile web and Django. Cool. So my question is, when do you use MongoDB versus Postgres? Like, what is your design choice? How do you choose between these two uh, databases depending on the application? Is your application currently requiring the use case of MongoDB? Because I'm just curious specifically. Um, Good question. Yes, um, but I won't say when though, because I don't know. But definitely, we're adding support for other databases. MySQL is already in like an alpha to try it out. SQL Server is coming pretty soon. So yeah, MongoDB and any other database is on the roadmap for like, so there'll be like multiple data sources that we typically support, and Mongo probably will be one of them, right? So, and I think probably by then you can drop in the Django stack because you don't need to write your controllers to uh, the models also probably can come in from directly the database with Hasura. Right? So lots of code trimming can happen over there. Um, I'm just wondering what's happening with the launch console. Um, mhm. Let me check if there are any other issues. Just going to refresh this once more. Could be something with my DNS as well. I'm going to disable the VPN. Probably it was, yes. Right. So um, for now, height. I have the console, the Hasura console. I'm going to create a users table over here. Maybe I'll just have like an explicit integer. And let's say email and some timestamp. Primary key would be the ID. That's fine. Created this table. Now, what I'm going to do is I'm going to add the remote schema, the Deno server that we created. But the thing is that our Deno server is running on localhost, so we need to expose this or probably deploy this somewhere that I can access it over here. As a quick local dev hack, what I'm going to do is I'm going to expose this over ngrok, which is a great service to do local development. I'm just going to open ngrok. I think it's .io. Oh, nice. The redirects are fine. I'll post this link. Right. So the way this works is it basically does some forwarding of your local host and port to a URL that they temporarily create for you, which will be live as long as your ngrok server is running. Right. So I'm going to expose my port 8000 using this server, and then I've got a URL from ngrok. There's a HTTP version and there's a HTTPS version. So I'm going to make use of the HTTPS version. So if I hit this endpoint, obviously GET request for this will not work. But if I do /GraphQL, this will in fact proxy to my localhost 8000 that's running over here. So this is exactly the same, but the URL is accessible from the outside world. That's the difference, right? I'm going to do a Deno GraphQL remote schema. Overall client header, we don't have any specific headers to pass in. Right, HTTPS I think is probably not working. So let's remove that. Has responded with 404. All right, so the reason being that we have to pass in the GraphQL endpoint, which is running on /GraphQL. Now this will add the GraphQL endpoint to our Hasura interface. And if you look at the Explorer, I'm just going to zoom in. Actually, I forgot to do that. Cool. So if you look at the Explorer over here on the left, we have the same set of schema that we created on the Deno server coming up over here, because we've just added it as like a remote schema. This users table is from Postgres. We don't have any users. For fetch user, I can do an ID and then get the first name and the last name. And there you go. So this is coming in from my local instance. So there's probably like a request, a post request going in, which is a 200. Awesome. So so this is proxying correctly. This is working. Just gonna zoom out a little more. Yeah. So what we've done is we've added a remote schema. So we're just proxying to our Deno GraphQL server through Hasura. And we look at the benefits of doing so. So the first benefit is you can now create a relationship between data in Postgres, which is managed by Hasura through the API. The API that is automatically generated for you through Postgres by Hasura, that can be merged with data coming in from an external GraphQL server like Deno. The use case here is that I have this fetch user which has specific details like the first name and the last name, and I have the users table which has the email and timestamps of the user created at and updated at, right? Now, I don't want to make two different queries from my front end. My front end knows that this is the user. I want the first name, last name, and the email and the timestamp in the same query. So what we're going to do is we're going to establish like a relationship between the two. We'll also like insert the rows here as well. We'll do hasura.io. The default values would be taken up, so that's fine. And two, assuming Drew would say gmail.com. And in the relationship, we'll have to create something called a remote schema relationship. So here we'll have to map a relationship from the table in Postgres to a field or a type in your remote server, which is the Deno server. The relationship name. So what we're trying to establish here is there is users data in Postgres and there is user metadata in Deno. So I want to be able to fetch the user metadata like the first name, last name, email, and whatever details from Deno GraphQL server with the configuration for fetch user type, the route query, with the argument mapping. So we need to be able to merge these data based on some kind of an argument, right? The argument has to be coming in from the remote server, which has an ID column, the ID argument. So this will be from column ID. mapping it to the column in Postgres database table. The users table has these 4 columns. The ID argument from the remote server will match to the ID value in the Postgres table. So that's what this configuration means. We're just trying to establish like a common ground between the data in Postgres and the data in coming in from Deno. And the common point is obviously the ID of the user, which is going to be the same in both the places. That's the assumption that we have. And however you manage data, I think the ID of the user will be common across different sources, right? So this could also be the email ID, because that will be like a unique parameter. If you want to do like an email as the relationship argument, then you need to accept like an email argument in your query type. So going back to our code, here on the fetch user, instead of ID, or probably on top of ID, we should also accept something called an email and then make both of these optional. So this would be email string, make this optional, and then let the user pass in any argument. And in your logic, in your resolver logic, you can like filter the user data based on email or ID value, right? So that's exactly what we can do with relationships. Here we're sticking to ID, and I'm going to click on save. The relationship name is user underscore metadata. And we already have like a couple of users data being inserted. So this is fine already. And what I'm going to do is do like a query, which would be users. Yeah. And ID, email, created that, did that. So this is data coming from Postgres. And what I'm going to do is also fetch the relationship data, which is user metadata. That also has the ID, obviously, but it also has the first name and the last name fields. And if we click on play, this is going to give us more data. So if you look at the response, the ID obviously matches in both the places. That's the condition by which we have merged these two data in like a single JSON object. Obviously, I can like remove the ID. We don't want to repeat data. So we have the ID, email, created at, updated at from Postgres, but the user metadata coming in from the Deno server. Over here as well, we have like the first name, last name coming in from the Deno server. So we've effectively merged data from Postgres with data in from an external server. This is technically data coming in from this JSON file in our GitHub repo. So if you're like building like a CMS, or maybe like have some content in JSON or Markdown, and you want to like merge some data based on some request on the DB, you can do so by making simple calls in your resolver and merging some data back into your Postgres. So so that's the GraphQL server from Deno from scratch. Now, obviously, this is the newest example that I can create, but you can obviously write some logic to insert into DB or fetch from DB over here. For fetch, obviously, you'll do like a fetch user ORM kind of a query connected to the database. And for mutation, you will do like an insert, right? So those things are up to the user to decide which library and framework to use and what kind of logic. But this is fundamentally what the code looks like. And depending on how many resolvers you have, you can export this out into different modules in your app, right? So that's fine. The next thing that we can look at is actions. So what if my my Deno server is not a GraphQL API, but I have like a Deno server which exposes some REST APIs. So if I go back to Oak over here, this is typically like a REST API example. I'm guessing somewhere over here they might have some REST API. Let's see if there is like a post request. Doesn't look like so, but with the Oak HTTP middleware, you can like create a REST API, and like this it's equivalent to what you do with Express JS, right? So now if you want to like merge this data into Hasura with the REST API, that's where the actions come into play. So the definition of action will be replaced with this types data over here. So instead of defining the types and the resolvers over here, what we'll do is the types will be defined inside of this action definition and the types over here in Hasura. And there's a webhook handler URL that you can give in. This URL would be the REST API endpoint where the logic for your resolver code would be written. So this in GraphQL syntax, this is how you write your resolvers. But in REST APIs, your resolver is technically just your endpoint, the post endpoint or a get endpoint, whichever endpoint, using it to return some data. So this logic would go inside that REST API. That will have like an endpoint, right? That endpoint will be over here. So this would be like probably fetch users, handler, and you will like forward client headers, obviously, and then click on create. So once you do that, you will get like a REST API running in Deno, but the GraphQL layer will be wrapped by Hasura. The types for your fields and your root queries will be defined over here, and the handler will be mapped to your Deno server, which is running like a typical REST API endpoint on post. This has to be a post endpoint so that Hasura will be able to call this with the query arguments or the mutation arguments that you have. And you can also parse the headers in your server. So that's the difference with actions. With remote schema, what we did was we created a GraphQL server, but with actions, you can skip this definition of types and restructure this resolver into simple REST API format, which accepts some post endpoints, and put the logic over there, and then run like a normal server on port whatever 8000 whatever, and then add that endpoint over here as handler. You will have multiple handlers for like as many endpoints you have in the REST API. You will add that many handlers and actions over here. So the benefit here is purely based on whether you want to write a REST API or you want to write like a GraphQL API. So it's more on the maintenance side of things on the custom logic. Also, another thing would be if you already have like an existing REST API written, you can like reuse them by adding like a GraphQL layer on top of that by just purely defining some types and then restructuring a little bit of the REST API before going live, right? So that's the use case for actions, right? So and in our upcoming release, currently we are at alpha, which is 1.4 Hasura alpha. I'm just going to look at the releases tab. Just going to take tags. We have the alpha one. So we have remote schema permissions over here. So once this becomes stable, probably by next week, what we can do is, I wanted to show you this today, but this is a whole different release and the multiple databases will be different in demo. Unfortunately, this is not available on cloud yet. So once it's on cloud, I can show you a demo on that. But the way it will look like is for your remote schema types for this Deno GraphQL server, the schema that you saw over here for fetch user, you can specify permissions as well. So that would mean that the data access for your remote schema is restricted based on what headers you pass into Hasura. So you can totally remove the authorization layer over here. You don't need to write any logic inside of this code to check if the user who's requesting. So that would be coming in the context, right? The context will have auth information. And based on this, you might be doing some conditional checks to see, okay, if this user is allowed to access this field and so on. You don't need to do that with Hasura. Once you've defined that permission layer in the UI over here, it's in the upcoming release. And once you do that, once you make a graphical call to Hasura to your Deno and types, the permission will kick in, and then the restrictions will apply, right? So you're effectively reducing the amount of code that you're writing for your authorization layer inside your remote schema. So that's coming up in 1.4. Hopefully this will be stable in the next week. Do not try this in production yet. This is in alpha, so to wait for stable release. We'll add that by a week or two, I guess. Right. So that's the benefit of doing like a GraphQL server. You can add like permissions for field level permissions for your remote schema. Awesome. So looking at the comments, one query about how to use Hasura action to trigger Django API. Right. So looking at this action that I showed you now, I think I have not created anything, but so the way your Django API will also work, right? You might have like a post endpoint handler. So this would be, let's say, my Django app.com slash fetch users. Your Django app, it's hosted on somewhere, and then there's a fetch users post endpoint. Or this could be probably even API slash fetch users. So for this, we would have defined some type query, and then you will declare the route query action, some arguments, some types. That's fine, right? So you will just do the same thing that I've mentioned in for Deno, wherein your Django app will have n number of routes. For each route, you need to define the GraphQL type, the definition of your GraphQL query, and then map it to your Django app endpoint. And then pass in appropriate headers. There could be some headers coming in from your client, which is the authorization headers. So allow that to pass through. That could be like a common secret that you share between Hasura and Django so that nobody else can call your Django endpoint directly. So that can be passed in through this header. And that should be it. You will define as many actions as your Django endpoints look like, and call in the API directly, right? So that's the way to go with Django. And it's not just about Django. This is applicable for any REST endpoint that you maintain in any language or framework. At the end of the day, we just need to map your types to a handler with actions. So this is applicable for Deno, this is applicable for Django, or any API that you write. Some real world business logic to validate the data in mutation case. Yes. I've actually done a few videos last year. This would be this repo. This would be Hasura actions examples. I'm going to post this over here. Yeah. So I have like a few data validations use case, if that's what you're asking, to validate the data. So there's some coupon code validation, there's some inventory check on an e-commerce app. But apart from that, all of these are actions. All of these are some real world use cases like sending email, and file upload with some binary hash. There's an image resize, and there's a Stripe payment API. So all of these are like real world e-commerce use cases that I've done. So you can check this out. Right. Another query from us: can you do a Hasura actions with Twilio Video API? Right. So shouldn't be difficult. Twilio Video API. Where's that? Just wondering what the use case is. I think I've seen your query on Discord. If I'm correct, I think you mentioned something around integrating their API. So with actions, there's nothing different over here as well for Twilio, depending on what query that you want to make from your front end. I'm assuming this is more of some kind of a mutation with Twilio. You're changing some data. You're probably doing some transformations or something. I don't think this is fetching of data, if I am correct. So you probably be creating a mutation over here, defining a mutation type, and have some input arguments, and then in your handler, which can be written in whatever framework you're comfortable, like no, let's say Node.js, Express, you can call in your Twilio API endpoint using some headers as well. I think Twilio will have some auth to prevent access. I don't see any docs over here for video. I think I need to sign up. All right. So yeah, maybe I'll look into this and then I can create like a sample action as well. If you're also very particular about your use case, I can look at that. But fundamentally, it's the same. Like you define your mutation types and then you write a custom server. Inside a custom server, just call Twilio or whatever endpoint that you have. But if you are very specific about a particular use case, then I can probably dig into their docs and then see if it's straightforward or yeah, Twilio serverless functions. Right. Serverless functions. Maybe there's also like a video generate access tokens. So I think there's some kind of there's some kind of auth involved as well. So the access token that you generate, I think, would be passed in as a header from Hasura. Twilio video responds with an authorization token. Cool. So that token will be passed into your action through the headers over here. So you can pass in a key, and then the value would be the token value, right? So looks so far fine for me. You have like an API key, API secret, and so this is standard stuff. Generate an access token, right? So this is I think there's some handler that they've written for handling some video stuff. This handler is where this will go inside your serverless function. I think this is probably already written as a serverless function. Uh, this can be hosted on probably AWS. I don't know where they're supposed to host this, but yeah, you can host this on a serverless provider, and then there'll be like an endpoint that provider will give you. You can add that as the handler over there. So this could be your AWS serverless function handler, or this could be, I don't know if you can host this on um, Twilio itself. I'm not very familiar with this yet. If Twilio provides like a hosted solution for this, or if they are like giving some SDKs only and then asking you to host on a different platform. I think Twilio probably lets you host serverless functions themselves on their platform. In that case, Twilio will have a URL that they'll give you. Yeah, looks like Twilio is doing the hosting stuff as well. So you'll get a Twilio URL, the serverless function URL. The function URL can be the webhook handler for your action. And yeah, once you call the mutation, it should call the handler, which goes to the handler that you've written over here. Right. So yeah, it looks fairly okay to me so far. But I think like a proper example would make sense as well with the right use case. I love these GIFs. So yeah, I think maybe we can like create a sample app with Twilio video, and then we can put it up on actions examples. Cool. I think that's mostly it on the questions today. All right, so it's not a mutation, it's a straight get. Right. So awesome. So then it'll be even more simpler. You'll make a query, and then it's going to fetch data from a handler, from a Twilio function URL, and you're getting some data back and then returning some response. Cool. Looks fine to me so far. So, but yeah, anyway, I think probably I'll take this up as I'll create an issue on the actions repo, and then I'll get into this to see how this is different. I will be happy to look at Twilio serverless functions as well. If I can write some serverless functions to add an action, that would be nice. So definitely look into this example for queries. Awesome. So that's mostly it for today. We've looked at Deno as the example. For today, coming up next is Felicia, which is 2 weeks away from the conference, a bunch of good speakers and workshops. So please register and do join in on 24th and 25th of this month. There's a bunch of workshops happening as well. I'm doing like the introduction to Hasura. So if you're new to Hasura, do join in to that as well. Interested in the Jamstack one personally to see what's up with the GraphQL queries and Jamstack ecosystem. And this is our SQL Server support. So pretty excited on that as well.